NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will find the vertex and the axis of symmetry for a quadratic function, given in general form f of x equals ax squared plus bx plus c. We will first state the theorem, then we will prove it by completing the square, and finally we will visualize minimum and maximum cases on a graph. Theorem: for f of x equals ax squared plus bx plus c. 1. The vertex is the point A with coordinates open parenthesis negative b over 2a, comma, for ac minus b squared over 4a, close parenthesis. 2. The axis of symmetry is the vertical line x equals negative b over 2a. Proof by completing the square. Step 1. Start with f of x equals ax squared plus bx plus c. Factor out from the quadratic and linear terms. Step 2. To complete the square inside the parentheses, add and subtract the term b squared over 4 squared. Step 3. The first three terms now form a perfect square. Rewrite them as open parenthesis, x plus b over 2a, close parenthesis squared. The remaining constant inside the brackets is, for ac minus b squared over 4 squared. Step 4. Distribute a to arrive at the vertex form. This yields f of x equals a times open parenthesis x plus b over 2 a close parenthesis squared plus open parenthesis 4 ac minus b squared close parenthesis over 4a. From the vertex form, the vertex is at x equals negative b over 2a and y equals 4 ac minus b squared over 4a. The axis of symmetry is the vertical line x equals negative b over 2a. Now, two cases. If it is greater than 0, the parabola opens upward, and the vertex gives the minimum value. Specifically, f of x is greater than or equal to for ac minus b squared over 4a. If it is less than 0, the parabola opens downward, and the vertex gives the maximum value. Specifically, f of x is less than or equal to for ac minus b squared over 4a. In this example, we will graph the parabola y equals negative x squared minus 2x minus 4 by following a clean, systematic 4-step process. First, we will find the vertex using x equals negative b over 2a. Next, we will build a small table of values around the vertex. Then, we will identify the axis of symmetry and the opening direction. Finally, we will plot the points and sketch the curve smoothly. Step 1. Find the coordinates of the vertex. For y equals ax squared plus bx plus c, the x-coordinate of the vertex is x equals negative b over 2a. Here, at equals negative 1 and b equals negative 2. So x equals negative, open parentheses, negative 2, close parentheses, over 2 times negative 1, which simplifies to x equals negative 1. Now plug in x equals negative 1 to get the y-coordinate. Y equals negative, open parentheses, negative 1, close parentheses squared, minus 2 times negative 1, minus 4, which simplifies to y equals negative 3. So the vertex is the point A at negative 1, comma, negative 3. Let's set up a coordinate plane and place our vertex. We'll use a window that clearly shows the vertex and a few symmetric points around it. Step 2. Create a small table of values around the vertex at x equals negative 1. A convenient symmetric set is x equals negative 2, negative 1, and 0. Plugging into y equals negative x squared minus 2x minus 4 gives. At x equals negative 2, y equals negative 4. At x equals negative 1, the vertex y equals negative 3. At x equals 0, y equals negative 4 again. Notice the equal y values at negative 2 and 0 confirm symmetry about x equals negative 1. Step 3. Identify the axis of symmetry and the opening direction. The axis is the vertical line x equals negative 1. We'll draw it as a dashed line through the vertex. Since it equals negative 1, which is less than 0, the parabola opens downward, making the vertex a maximum point. Step 4. Plot the symmetric points and sketch the curve. We'll plot the points negative 2, negative 4, and 0, negative 4 on either side of the vertex. Then we draw the smooth parabola passing through these points and opening downward. Example. In this lesson, we will graph the parabola y equals 3x squared minus 2, following a simple algorithm. Identify a, b, and c Find the vertex using x equals negative b over 2a. Compute the y value at the vertex, make a short table of values, and then draw the curve. Step 1. Identify the coefficients in the standard form y equals ax squared plus bx plus c. For our function, a equals 3, b equals 0, and c equals negative 2. Step 2. Find the x-coordinate of the vertex using the formula x equals negative b over 2a, substituting b equals 0, and a equals 3 gives x equals 0. Step 3. Plug x equals 0 into the function to get the y-coordinate of the vertex. Y equals 3 times 0 squared minus 2, which is negative 2. Therefore, the vertex is the point 0, negative 2, and the axis of symmetry is x equals 0. Step 4. Complete a quick table of values around the vertex. We will use x equals negative 1, x equals 0, and x equals 1. Substituting gives y equals 1, y equals negative 2, and y equals 1. Step 5. Let us do and y equals 1. Step 5. Let us draw the graph. We place an axis system and mark our vertex at 0, negative 2. Next, we plot the points negative 1, 1, and 1, 1. We sketch the axis of symmetry at x equals 0, and then draw the smooth U-shaped curve. Summary. We identify. Example. We will graph the parabola from the equation y equals x minus x squared, following a clear, structured algorithm. Standard form, vertex, axis of symmetry, and direction. Let's set up a coordinate plane, and then build the graph step by step. Step 1. Rearrange to standard form y equals ax squared plus bx plus c, and identify the coefficients. From y equals x minus x squared, we write y equals negative x squared plus x. So at equals negative 1, b equals 1, and c equals 0. Step 2. Find the vertex. The x-coordinate of the vertex is negative b over 2a, plugging in a equals negative 1, and b equals 1 gives x equals 1/2. Then substitute back into y equals x minus x squared. Y equals 1/2 minus 1/4 equals 1/4. So the vertex is at a, open parenthesis, 1/2, 1/4, close parenthesis. Step 3. The axis of symmetry is the vertical line x equals 1/2. Because it is negative, the parabola opens downward, and the vertex is a maximum. Step 4. Plot a couple of easy points and sketch the parabola. Notice the x-intercepts at x equals 0 and x equals 1, so the points 0, 0, and 1, 0 lie on the graph. We will draw a smooth curve through these points, and the vertex symmetric about the axis. Example. In this lesson, we will find the minimum value of the quadratic function 3x squared minus 12x plus 5. We will follow 2 clear steps. Step 1. Find the x-coordinate of the vertex using the formula x equals negative b over 2a. Step 2. Evaluate the function at that x value to get the minimum. Step 1. Find the x-coordinate of the vertex. We use x equals negative b over 2a. Here, at equals 3, and b equals negative 12. Substitute to get x equals negative parentheses, negative 12 parentheses, over 2 times 3. That equals 12 over 6. Which simplifies to x equals 2. Step 2. Evaluate the function at x equals 2 to get the minimum value. We compute f of 2 equals 3 times parentheses 2 squared parentheses minus 12 times 2 plus 5. That is 3 times 4 minus 24 plus 5, which becomes 12 minus 24 plus 5. That simplifies to negative 12 plus 5. So the minimum value is f of 2 equals negative 7. To build intuition, let us visualize the parabola. Here is the coordinate plane, and the graph of f of x equals 3x squared minus 12x plus 5. The parabola opens upward, so its vertex is a minimum. We mark the vertex at x equals 2, y equals negative 7. The gold dashed lines show x equals 2 and y equals negative 7. Watch a point sliding along the curve toward the vertex, the lowest point. This confirms the minimum value is negative 7 at x equals 2. Final answer. The minimum value of the function is negative 7 at x equals 2. In this lesson, we will read key information from a downward opening parabola to determine the signs of the coefficients a, b, and c in ax squared plus bx plus c, and then decide how many real solutions the equation has. We will follow a simple algorithm. Step 1. Determine the sign of A from the concavity. Step 2. Use symmetry or the sum of the roots to decide the sign of B. Step 3. Use the product of the roots to decide the sign of C. Finally, count the intersections with the x-axis to decide the number of real solutions. Here is our working diagram. The parabola opens downward. The vertex is at 0, 4, and it crosses the x-axis at x equals -2 and x equals 2, which are symmetric about the y-axis. We will use these visual facts to read off the signs of A, B, and C and the number of solutions. Step 1. Determine the sign of A. A downward opening parabola means A is less than 0. We can emphasize the concavity by showing downward arrows on both sides. So we conclude A is less than 0. Step 2. Determine the sign of B. The roots are symmetric x sub 1 equals minus x sub 2. That means their sum is 0. By Vieta's formula, the sum of the roots equals negative b over A, so negative b over equals 0, which implies b equals 0. We will highlight the symmetry axis and the two symmetric roots. Then we will write the equations to show why b equals 0. Step 3. Determine the sign of C. One root is positive and the other is negative, so their product is negative. By Vieta's formula, the product equals C over A. Therefore, C over A is less than 0. Because we already know A is less than 0, it follows that C must be greater than 0. We mark a plus sign near the positive root and a minus sign near the negative root to emphasize the product is negative. Then we show the product equation and the conclusion C greater than 0. Finally, determine the number of real solutions. The graph crosses the x-axis at two distinct points, so there are two real solutions to ax squared plus bx plus c equals 0. We indicate both intersections on the x-axis. Then we summarize all results. This reading strategy works for any quadratic graph. Concavity gives you A, symmetry and root sum reveal B, the product of roots reveals C, and the number of x-intersections tells you how many real solutions there are. In this lesson, we will determine the signs of the coefficients A, B, and C, and the number of roots for a quadratic whose graph is a parabola that opens upward and just touches the x-axis at a single point to the left of the origin. We'll proceed in two parts. First, figure out the signs of A, B, and C, and second, decide how many solutions the equation has. Let's sketch a clear diagram. We draw x and y-axis. Now plot a representative parabola with vertex on the x-axis at x equals -2, so the graph is tangent there. We'll mark that tangency point and the horizontal tangent line. Step 1. Determine the sign of A. The parabola opens upward, which means the coefficient of x squared is positive, so is greater than 0. Step 2. Determine the sign of B using the sum of roots rule. For a quadratic ax squared plus bx plus c equals 0, the sum of the roots x prime plus x double prime equals negative b over A. Here the graph is tangent to the x-axis at a single point left of the origin, so both roots coincide at a negative number. That means the sum is negative. If x prime plus x double prime is less than 0, then negative b over A is less than 0, so b over A is greater than 0. Since it is positive, b must be positive. Step 3. Determine the sign of C using the product of roots rule and the y-intercept. The product x prime times x double prime equals C over A. Since the repeated root, r is negative, r squared is positive. Therefore, C over A is greater than 0, and with a positive, C is positive. We can also confirm this by looking at the y-intercept. F of 0 equals C, which is clearly above the x-axis in our sketch. Step 4. Determine the number of roots. Because the graph just touches the x-axis at one point, the quadratic has a repeated root. Algebraically, this means the discriminant is 0. Therefore, the equation has exactly one solution, a negative double root. To summarize, opening upward gives a greater than 0. The negative repeated root forces B positive from the sum rule and C positive from both the product rule and the positive y-intercept. The equation has a single repeated solution, which is negative. In this lesson, we read a quadratic graph and deduce the signs of the coefficients A, B, and C, and determine how many real roots the equation has. We will use a concrete example with the same features as the provided sketch. An upward opening parabola with one negative and one positive x-intercept, and a y-intercept below the x-axis. The function y equals x squared minus x minus 2 has exactly these properties. Roots at x equals -1 and x equals 2, a y-intercept at -2, and a minimum at x equals 0.5. Step 1. Determine the sign of A. The vertex is a minimum, so the arms of the parabola open upward. That means A is positive. So we conclude a greater than 0. Step 2. Determine the sign of B. The sum of roots equals -b over A. Here, the positive intercept at x equals 2 is farther from the origin than the negative intercept at x equals -1. So the sum x prime plus x double prime is positive. Since it is positive, -b over a positive implies b is negative. Step 3. Determine the sign of C. The y-intercept is below the x-axis, so f of 0 equals c is negative. Equivalently, one root is positive and the other is negative, so their product is negative. And since c over equals the product, c must be negative given a greater than 0. Finally, how many real roots does the equation ax squared plus bx plus c equals 0 have? The graph crosses the x-axis at 2 distinct points. Therefore, there are 2 distinct real solutions. Summary: A is positive because the parabola opens upward. B is negative because the sum of the roots is positive while it is positive. C is negative because the y-intercept is below 0, and equivalently the product of roots is negative. The graph intersects the x-axis twice, so there are 2 real roots. Great work! Reading coefficients directly from the graph is a powerful and quick way to understand quadratics at a glance. Example: from the graph of the quadratic function y equals ax squared plus bx plus c, determine the signs of a, b, and c, and also determine how many real solutions the equation ax squared plus bx plus c equals 0 has. We will build a clean parabola diagram to reason visually. Step 1. The sign of A. Notice the parabola opens upward. When a parabola opens upward, the leading coefficient A is positive, so it is greater than 0. Step 2. The sign of B. The vertex of the parabola is in the first quadrant, so its x-coordinate is positive. The x-coordinate of the vertex is given by x sub v equals -b over 2a. Because x sub v is greater than 0, we have -b over 2a greater than 0, which means b over 2a is less than 0. Since it is positive, b must be negative. Step 3. The sign of C. At x equals 0, y equals c, so the y-intercept is c. On the graph, the intersection with the y-axis is above the x-axis, so c is positive. Step 4. The number of real roots of ax squared plus bx plus c equals 0. If the parabola does not cross the x-axis, then there are no real solutions. Algebraically, we use the discriminant delta equals b squared minus 4ac. When delta is less than 0, there are no real roots. In our diagram, delta is less than 0. Summary: the parabola opens upward, so A is positive. The vertex is to the right of the y-axis, which makes x sub v positive, so b is negative. The y-intercept is above the x-axis, so c is positive. The parabola does not intersect the x-axis, so there are 0 real solutions. Final answer on screen. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.